canonical equations of the method of forces when finding forces in the elements of statically indefinable system. The article number 3.3 from the book Mechanical Systems Calculations of the Marine Facilities. Which is a physical sense of the canonical equations of the method of forces. After when finding the support reactions and the forces in the elements of statically indefinable system, we decided the main issue of statics as finding of support reactions and developing drawing up the balance equations of the mechanical systems. But sometimes the number of the connection links with the supports or just internal connection links in the mechanical systems are excessive. So we have unnecessary links. This means that these links are necessary for construction of the mechanical system, yes. But these links are excessive when we determine the forces of supports and the forces in the mechanical elements of the mechanical systems due to the number of the variables could be of the variables, unknown variables, subject for finding the variables. The number can be more than number of balance equations, which is for integral mechanical system in the flat state. I mean, on the plane is equal to 3. We have 3 mathematical equations of balance, and could be if the variable subject to find is more than 3, so we have not enough the equations of balance to find all forces acting on the mechanical system, in particular if we are talking about the external static indefinability. Okay, the canonical equations is the kind of the condition of the deformation compatibility. So we cannot consider if we have as forces are known subject to find more than the equations of balance, or the balance equation is not enough. So we have to consider the deformation of the mechanical system. And only after considering deformation, we can find the support reactions and forces inside the mechanical system. So the canonical equation is a kind of the condition of the compatibility of deformations in the mechanical system. And we have canonical equations to substitute the required missing connections, which we discard in the assigned mechanical system statically indefinable when we develop the main mechanical system for the assigned indefinable. The main mechanical system we use for determination of the balance equations. But the main mechanical system is statically definable, and this due to we substitute the discarded extra links in the connections of the mechanical system with the supports. We substitute them by the forces, but the forces acting on behalf of the links, assuming that these forces we have to find the displacement in accordance with the balance equation. So this is a complement of the balance, the canonical equations of method of forces, or any canonical equations in mechanics, and the concepts of the elasticity of the mechanical system. The canonical equations are the complement of the balance equations to the required number of the equations to find all the required support reactions and forces inside of the mechanical system, in the element of the mechanical system. When we substitute the discarded links, extra links, creating in process of the creation of the main system of the assigned system, we have to assume that the displacement in the method in the discarded links and connection of the mechanical system have to be equal to 0. This equality of the displacements in the discarded connections of the mechanical system when creating the main system statically definable of the assigned statically indefinable system mechanical. This absent connections we substitute by the forces. That's why we say that we consider the canonical equations of the method of forces to find the forces in the element of statically indefinable system. So the displacement in these discarded links have to be equal to 0. And as well, we substitute, we assume the independence of the acting forces or acting discarded forces, which we adopt instead of discarded extra redundant connections. So as the forces in each of the redundant connection, which we cut out of the system, creating the main system of the assigned system, each of the forces caused the displacement in each of the direction of the other forces and itself. So the displacement in each of the direction, each direction of the discarded connection is the total of the direction, total of the set of direction of displacements, total of set of displacement caused by the force in each of the discarded in force substituted for each of the discarded connection. So this is in the direction number I. For example, could be force direction or another one direction can be. Each is the total of the displacement in direction number I. It can be in a definite one. Discarded connection could be the hinge. Maybe we discard the hinge, or we reduce the number of the links of the hinge, or maybe it's in embedding. We transform the embedding to do the main system of the assigned statically indefinable system. We when we do the main statically definable system, perhaps we can reduce the level of the embedding. So instead of the embedding, we assume that there could be the hinge, maybe a fixed hinge or sliding hinge, and the other forces which differ the embedding in compare with hinge, we substitute by the forces. But these forces have to be enough to keep the same conditions as conditions of the support as we had on behalf of the embedding. Or we can substitute the fixed hinge by the sliding hinge with only one component of force of the support reaction instead of two components of the fixed hinge. In this case, we can substitute one of the links of the fixed hinge by the force and consider that instead of in the main system, instead of the assigned statically definable system, we can consider in the statically definable created main system as the simple hinge, sliding hinge, but considering together with the force instead of other simple link when we did consider the fixed hinge, etc. So in each direction, maybe in direction with the index I, we have displacement, total displacement, delta the letter delta, upper size delta, with the index I equal to the upper size delta index I1. So this is a displacement in the direction of the discarded link number I on behalf of the force. We substitute instead of the discarded direction number 1. So the first index indicates in what direction is the displacement considered. The second one, what is the cause of the emergent of the displacement delta upper sized y first, for example. This means that we next summand, second summand is displacement in the discarded connection number I on behalf of the force which we substitute instead of the discard the connection number 2, etc. And the final is almost final is displacement in the connection number I, as we have here. The delta upper size at I, n is the cause of this displacement. Cause is the force which we have to substitute in the place of the discarded link number n. And with well, we have to add the delta upper side of in the direction of y as well by the cause raised by the cause of the external load assigned of the assigned system. The same external load we consider acting on the main system, statically definable main system, which for all discarded links to make it statically, to make assigned system statically definable, and we substitute the absolute links which we discard by the forces. And this total displacement has to be equal to 0, as if we would not discard the link number y, if number I, the displacement would be 0. So this is a condition of the equivalence of the stress of the state of the loaded mechanical system, main mechanical system, to the assigned statically indefinable system. So as we discard n number of the discarded n low case n letter, we consider the number of the static indefinability, number of the variables besides of the variables due to the balance equations in the which we have on the flat state. On the plane we have 3 balance equations. So this is n is n lowercase letter. How many variables we have more than 3 for the flat state of the mechanical system? And the next is etc. And we have n in the system of the canonical equations. We have n canonical equations, which each one correspond to equality to 0 of the displacement in each of the discarded link to do the statically definable main system of the statically indefinable assigned system. Besides of the independence of action of each force in the discarded links when doing the main system and substituting these links by the forces, and considering the total action, the forces on the displacement, and each, for example, the number I discarded link direction, considering as well the displacement in this direction I on behalf of the external forces F, we have the same equations for all n discarded directions. So we finally have the system of the equations. To decide the system of equations, we have to adopt as well the unknown variable subject to find for the canonical equations. And the second assumption, besides of the independence of action of any forces in each of the deformation, which it's possible to do just summarizing of this displacement to find the total displacement in the equation when we equal the total displacement to 0 in each direction. The second assumption is that for the canonical equation, to draw up the canonical equation, we have to adopt the assumption of the proportional elasticity. So we assume that the displacement in each of the direction I, instead of in the links discarded and substituted by the force xk, xy is in this definite point, we substitute by the displacement by the force xy in the direction y. But the displacement in this direction is caused not only by the force xy, but all other forces in the mechanical system. We substitute instead of the extra or redundant connections, which is a number equivalent to the number of static indefinables of mechanical system assigned. So the concept of the elastic proportionality, we account by the use of the formula like each displacement in each direction I is equal to the product of the unit displacement, the delta lowercase ik, the same indexes, and the delta uppercase is displacement, and this is displacement on the unit load. So to do practical use of the canonical equations when finding the displacements and finding the when deciding the rule of the deformation compatibility of the elastic system, we assume that this is a deformation on unit load. So when we do product this unit, the deformation of unit deformation or deformation of unit load, when we product this deformation by the force acting in this direction k as a cause of the deformation. That's why we finally have the displacement on the any magnitude of the force acting in direction k. So the canonical equation transforms to another form, like here we have, instead of each summand, we substitute the product of the unit displacement or the displacement of unit in the y direction dependence on unit force, product by the actual magnitude of force in this direction, which is the second index in the lowercase delta. So the same as we have on the second one, force in the direction number I, the same we have on k force. K force is support action in the direction, or in other, maybe not only support direction, maybe any force when we substitute the assigned system by the main system, statically definable, and providing as well the system of forces instead of the discarded the links when transforming the system to statically definable state, etc. And we have finally the displacement of unit force on displacement, unit displacement to displacement under influence of unit force. Force in direction n and the displacement in direction e, and plus as well the displacement delta uppercase with indexes I, E, F. I mean that this is in direction I is a subject of the canonical equation I, displacement of the discarded number I linked direction, and due to the external force assigned for the mechanical system. Okay, so finally, as we have I, so we have the system of the equations. This is a system of canonical equations of the forces method, and each of the equation is the part of the compatibility of deformation condition when we decide the statically indefinable system, n times statically indefinable system. So we have n lowercase index canonical equations of the force method, and we have to find with users system the equations of the forces of the discarded, which we adopt instead of the discarded connections when doing the statically definable main system of the assigned statically definable system. After this, we have only one kind of the decision, just only one set of the one system, one set of the forces or efforts. Maybe some of them are just rotating moments, not so much important for the decision of this equation. This could be forces or rotating moments, that components of forces, etc. All what we consider as a substitute of the discarded links when doing the statically definable main system of the assigned statically indefinable system, and as well be consider the action in this definite one direction for the first one, etc., of the external load. So the first index corresponds to the number of the equation in the system. The second index corresponds to the number of the summoned in this system of the canonical equations of forces method, which are these equations in the system. The rule of the compatibility of deformations in the statically indefinable system assigned. Questions and comments. The physical meaning of canonical equations of the method of forces. The canonical are the missing equations that complement the balance conditions of statically indefinable systems. So number of the canonical equations is the number of static indefinability of system, and we need these canonical equations instead of the balance equations for the integral system on the in the flat state. So in the plane we have 3 balance equations. Maybe in the space we have more than 3. We have 6 for integral system. For if we consider as well the coordinates of the parts of system, so we can have any more the balance equations. It's not so much important anyway after determination of the degree of static indefinability of system and finding how many we have to have the canonical equations we consider in the next for the statically indefinable system, the system as deformable, and all coordinates of possible independent deformation or the number of the required balance or having balance equation to the number of the required equations to have all the unknown variables. So are the set of the balance equations. 3.3.2, the correspondence in the form of canonical equations of the resulting main system and the given statically indefinable system. The main system satisfies the assigned statically indefinable system by the use, by the complement of the canonical equations, because finding the forces by the canonical equations, forces of the discarded coordinates of discarded links of the statically indefinable system when finding the main system. So we next find this required forces by the canonical equations, and this complement statically definable main system for the equivalence of the assigned statically indefinable system. 3.3.3, the concept of independence, the linear superposition of the actions of the forces when drawing up the canonical equations. We, when draw up the canonical equations, assume that each force which we adopt instead of the discarding links when doing the main system statically definable instead of the assigned system statically indefinable. So each force acts independent. And so the displacement in each of the direction of the cut of extra redundant links to do statically definable main system. Each direction satisfy the displacements of all the independent forces of adopted instead of all of discarded extra or redundant links of the assigned system to do the main system. 3.3.4 proportionality, the effort of each direction of all discarded connections and the displacement in the direction of each discarded connection when drawing up the main system of the considered mechanical system. We as well assume the proportionality and the elasticity of the deformation in each of direction of the each discarded link of the assigned system when doing the statically definable main system. And to do that, we can find the displacement in each of the directions on behalf of assumed action of the unit loads in the discarded connections. And next, we can use that as for any of the load, maybe no unit, but any other magnitude of the load due to the product of the deformation of unit load by the magnitude of the actual load in this definite one direction. So we use the by proportional elasticity concept of the mechanical system. Thank you.